Hey, welcome everyone. I'll just start with a quick introduction about myself. Today we are going to be focusing and talking about modern data platform. I'm Chief Technology Officer at Sama Technologies, focused on data and analytics as our core. I personally have been in this space, with data and analytics for around 30 years. And the focus has always been how to operationalize an innovation or a new technology for a better business outcome. It is not about the technology. We are all technologists, and most of us on the call here probably are technologists, but it is about how technology is used for a better business outcome. How is it becoming a value add in this overall value chain? That should be the focus, and that has been my focus, is how to operationalize this technology for a business advantage. With that, Gopal, I'll hand it back to you, and we'll get started.
Sure. Thanks, Rajiv. I'm Gopal Swaminathan. I am the Vice President and a partner at Sama Technologies, and lead the insurance and financial services practice. So been in the industry over 2 decades, focusing purely on data analytics. And with that, I will jump right on. Rajiv, from the point that you said about creating that value chain in the organization to enable better business outcomes. So there has been a lot of hype on modern data platform almost in the last 5 years. So what do you see? How do you see that? Why is that sudden hype?
Yeah, so as such, the data has been taking and has not really taken, but has been deepening its impression on organization at a center stage to be a key driver for a better business outcome, what we talked about before. So the hype, I believe, is mainly driven, and it's not a hype in that sense. It has been much more in the center because the organizations are becoming more data centric for the right reason, is to be able to drive those better outcomes. So that's for one thing for sure. Second thing is that the agility required. Ultimately, everything we have talked about so far got us to a point where we had scalability and elasticity and capabilities, but the agility to be able to respond to a business need and change has still been missing. As a business, that's what they are demanding, and that's what we are able to now provide with modern data platform, and hence it is receiving its due focus or importance, if you will. And obviously, every analyst today, Dave Gartner or anyone else, will tell you, and I don't think, unless you're living under a rock, that's no longer a surprise, that data is, and that is the core charter. If you ask a company today which used to sell seeds, they'll say we are a data company, because that's becoming a more important asset, understanding where and how those seeds are being used than the seed itself. I mean, seed is important because that's what their business is. Why they're calling themselves a data company? Because data is becoming the core asset, if you will. So those are some of the reasons why today this is the center stage.
Yep, no, definitely, Rajiv. Definitely that importance in data. And wanted to go a little back on, say, a decade ago. There are a lot of focus on big data, and then now with cloud, how do you see that correlation between both? And then I'm sure there are several other examples that we have worked in the past. So do you want to pick up something and show how that transition is and how the difference is?
Sure. I mean, first we'll remember those 3 V's, right? We started with saying that, hey, we have velocity, volume, and variety. We talked about cloud. Why cloud? Well, it gave me elasticity. I can expand and contract as I want, but at the right level of granularity. If I just wanted CPU, if I just wanted storage, if I just wanted network, I can go change those as I need, change the technologies I need. So elasticity in multiple sense of word became available with cloud. So those have been there. Then again, coming back to this agility that we have been talking about, there's so if big data, just I'm really, I mean, they are just different terms, but just putting, roughly speaking, big data if it kind of address the three V's, and cloud address the elasticity, then this as a modern data platform, we are addressing basically using those things, addressing the agility. So that's kind of one way to be able to look at it. So let's look at it in terms of how is that addressing agility, for example. I'm going to take, to your point, Gopal, take a very small example to be able to do that. If we write a piece of code which we wrote 30 years ago, a SQL, we maintain it. If a system writes it today, any semantic layer generator, any reporting tool, any ETL tool would generate that SQL for you if you are able to supply certain parameters. And then it as in the program writes the SQL. If program writes the SQL, program maintains it. If you write the SQL, you maintain it. So similarly, can we take this modern data platform approach from a parameter configuration driven as opposed to from a SQL writing point? And if we take and shift that model, saying that there should not be any line of code in there, we should be telling a system what needs to be done. Now, once you've told the system owns that. And once system owns it, you just have to tell, no, do this differently in a parameter way, in a configuration way, versus coding it. And that improves agility, that improves quality, because you're no longer coding for it, you're configuring for it. So that would be an example of what's possible here.
Sure, no, that's great. So moving towards configuration versus coding, definitely it's not just how better we build it, but also from a future maintenance standpoint, it's going to be of a great reuse. And we have already started seeing that in some of our existing implementations. But Rajiv, while talking about this, what are the other key differentiators for a modern data platform? What would primarily drive any enterprise to look at how should I modernize my platform?
Sure. Now, let me actually do one thing. I'm going to share one slide to kind of better talk about that. Let me quickly share that. Okay. All right. So let's talk about this for a second. There are two factors I want to really bring out here. First of all, why are we even doing all this, right? Why modern data platform? Why even attempt to build this? Whether modern data platform, whether data warehouse, big data, cloud, anything, from a data platform point of view, had three, and always had those three kind of key drivers. Discoverability. Can I come in and find what I need as an end consumer or as an analyst, whatever? Can I find what I need? So discoverability. Meshability. The value of data is the fact that I can combine two different places, two different seemingly non-joinable, sometimes joinable sources, and find 1 + 1 = 3. By combining these two disparate data sources, I can actually find something at that intersection which was not known before. So that meshability or joinability of data. And third is governance. You could be doing all this in an Excel spreadsheet. We do it here because of the governance aspect of it. So if these were the three drivers, then how do we address that? That's one kind of I want to put in, saying that, do I improve discoverability, meshability, and governance? And second objective is that technology is absolutely, and there's no surprise to anyone on this call here, that is accelerated and has accelerating. So that means that is hyper fragmentation. That means for anything you want to solve for, there are multiple vendors available, and too many for that matter. What does that lead to? That leads to consolidation, which has already started. It's happening more and more. More of the cloud players become more powerful and more kind of encompassing. They'll bring those technologies in, and in that, some technologies win, some technologies will lose. So the core question then, a person who's designing this modern data platform is, how do I future-proof this? How do I select a technology and then not be caught tomorrow when that technology goes away or gets consolidated into something else? Oh, I have to redo this, or I have to refactor a lot of the coding and all those things. So how do I future-proof it? So rather than, so I'm going to kind of address both in this question. One, how do we look at this from a discoverability, joinability, and governance? And second is, how do I future-proof it? So let's start with that future-proofing aspect. If we decide based on technology, then we are tying ourselves to that technology. When that technology gets decided and finalized, we are going to be depend on it. And when that changes, there will be a lot of changes. Instead of that, if we think in these dimensions which are listed there here, and think about what is it that we want. So think of each one as a choice of where we are today and where we want to go. So if we are at a uh, uh, take asset compliance versus base. If we need a complete two-way commit and compliance system, asset compliance system, versus for marketing data and for a lot of that, eventually consistent, which most of us would have heard of in context of either Hadoop or in a lot of other databases, where we say eventually consistent when there are multiple copies, reduces the complexity and cost quite a bit. Yes, there might be a delay of a few seconds to minutes from one copy to another, but hey, maybe acceptable for our use case, then base is fine, and we can do that. So similarly, and I'll talk about a couple of more dimensions, but the point is that if we choose on technology, that's first step number one, saying this is what I need, does this technology provide me that or not? So this becomes kind of a North Star or a litmus test for choosing the right technology. And very important, second is abstraction. We do not tie directly to that technology, rather go through a comprehensive interface or an abstraction point. Good example would be like something like Java. So if that was an abstraction over multiple processors or multiple operating system, then you could write one and it will translate to any. Similarly, rather than writing directly into picker technology, let's say you're going to use Airflow for workflow management. Rather than everyone writing directly for Airflow, if you were to say, hey, this is how a fork happens, and you have a generic way of describing that in a metadata or in an abstracted manner, then what happens is that you can just write one interface saying, oh, this is the command for fork in Airflow, and this is how it's going to do it. Tomorrow, if it is another technology, you can just rewrite that interface. Everything else is taken care of. So abstraction, although it has some overhead, is a very powerful tool in future proofing. And the way you select a technology is by these dimensions, as opposed to by selecting, saying that, hey, does this technology does what I want today or not? Then it will not address the flexibility and capability that you need in the future. So I spoke about acid versus base. You could talk about ELT versus ETL. You could talk about whether you are looking for virtualized or physical integration. And all of these answers are going to be somewhere in between. They're going to be different for where you are today versus where you're going. And hence, this becomes a great roadmap tool to be able to say, this is where I'm today. This is where I want to go on these dimensions. These are the technologies we have. Will it take me where I want to go? No, there is a huge gap. There is a small gap. Let's fill it through some enhancement. It's a huge gap. Let's find the right technology which will get me where I want to go. And this is how I'm going to deliver it. And through that abstraction and interface, so that I'm protected against the future change. When that technology changes, all I need to do is rewrite that interface, and abstraction really helps me reduce my rework in the future. So hopefully this kind of gives a broader sense of how we modernize with thinking about these kind of aspects, these dimensions, as opposed to thinking at technology in. We need to think about our need and functionality out, and then choose a technology which will fit those blue boxes where we want to go.
Great answer, Rajiv. And there's a follow-up question to that from Ankur. His question is, should everyone then choose abstracted and orchestrated or unified and integrated? So what's your point? Is it always everyone should go on the blue boxes or orange, or what's the idea behind that?
Yeah, it's funny, right? Good observation there. I should definitely flip a couple of blues before the orange. It just looks like as if we are moving, it's like political spectrum. We are moving to from left to right. It's not true. And answer to your question is, that it will depend on what we do. There is a value, huge value in being unified. At one point, one of the largest modern technology phone company in the world today had a unified. They had a decision around 15 years back. I used to work, do some consulting there, and the idea was that everything should be under one platform, so that doesn't matter if the reporting tool is okay. That's okay, because it's all under one platform. It's all going to talk much better to each other. So you're giving up that best of the breed for that capability to be able to use a unified system. You can compare the same way. Unified and integrated would mean that I'm choosing one cloud provider. Doesn't matter what kind of RDS service, relational database service it gives. I'm going to use that because they're going to improve anyway over time. I will have middleware, which is going to talk to everything. I will have a good workflow capability, which will know what to do. And the idea there is that it will kind of even out over time. If there are rough edges, it will even out over time, but it's better to stay in one area. That's one line of thinking, which is talking about that unified. Versus abstracted is saying, hey, there are a lot of technology, right technology for right things. Yes, 12 dimension doesn't mean 12 technologies. Maybe this means choice of 3 or 4 technologies. Can I rationalize across best of the breed? As soon as I say best of the breed, I have an ensemble now. I'm not playing one instrument, I'm playing 4. And if I'm playing 4 instruments, I do need orchestration. I do need abstraction so that I can talk to all of them through a common language. So it will really depend on that core decision, that am I ready to commit to this, assuming that over next certain years, no one has seen the future way out there, and no one has seen tomorrow. But point being that if you think for next 4 to 5 years, 3 to 5 years, we can commit to this technology and we're going to stay here, you have an opportunity to go down the left-hand side route, which is going down the route of unified and integrated, and you are willingly submitting to that fact that I might have to deal with some inefficiencies, but it's okay because they will improve and we'll be able to do that. That's the line of thought on that side. And as I mentioned, on the right-hand side, it's all about being able to choose the grid. And I think a lot of us have made those choices based on the and changes, what we are expecting to change. If you generally speak that future is changing, I can't see tomorrow too far, likely to fall on the right-hand side. If you are able to commit to this and say, I'll work within that, you can work very effectively on the left-hand side. Left-hand side as in integrated and unified.
Perfect. No, that definitely clarifies, Rajiv. See, as a follow-up to this, based on what our Ankur asked, right? So what does it really mean for a technologist? So are there any key points that you would want to suggest for technologists on when there is a migration to a modern data platform?
Right. So I think we as an organization, I mean, as technologists, right? We don't mind, like we pick up on new technologies. Basically, we learn new languages. We learn new tools. I think the overall this thought process of how do we leverage a technology and abstract it, that is a keyword. How do I abstract it so that I am not tying myself directly to that technology, but rather utilizing that technology through this layer. So by creating that, when you know that underlying landscape is changing all the time, that's kind of one thing I would highly recommend that that we do that. That's from the technology and infrastructure technology stack point of view. Second one is the overall thought process, going back to configuration versus code. Can I move more to configuration? How do I move to configuration? Well, because I can right now metadata driven transformation as opposed to just metadata driven select statements, which we have done for a long time. Can I drive the data ingestion, data pipelines, basically transformation, data quality, all these things from metadata driven framework as opposed to writing a line of code for it. That would be a second most important transformation we can do. So abstraction, being able to be driven more and more from a configuration versus code, and that enables actually a world of possibilities. Once we have the right type of metadata driven infrastructure and so on, you can leverage things like AI/ML. You can leverage heuristic and rule-based engines for doing stuff for you, because that engine has something to think, something to take as a parameter, as opposed to reading a spaghetti code saying, oh, this is how you're organized. This is what your knowledge graph looks like. This is what your metadata structure looks like. Okay, maybe I can help you. I, as in that piece of program, AI/ML or heuristic or engine, can help you make certain decisions and drive your data pipelines and so on, as opposed to you building it. So I think it's about leveraging. It's about abstraction in both technology and in our transformation or data pipelines. I think that's why the word abstraction kind of keeps coming back. But one is about technology abstraction. One is about actual metadata and how we abstract out the logic. And so that the engine is void of us giving specific instructions and being driven from these parameters. So configuration versus code. I think those would be the things I would kind of focus on, and we can focus much more on what the business need is, and not be in minutia of how a lookup happens and how can I make a lookup more efficient, or how do I do that. Those things we can move away from and be more focused on the business outcome, and be truly be driven by the business need and how we translate that into these configurations.
Sure, Rajiv. And we have 5 more minutes left. I just want to have ask you one question related to digital transformation. And while we do that, anyone from the audience, if you have any question, please feel free to post it on Q&A. And back, Rajiv, my question is, you spoke about technology and then business outcome. Digital transformation and data transformation has been one of the core things that every enterprise is looking at. So how would you tie modern data platform with the digital transformation?
Right. So it is absolutely an answer to a question. So digital transformation is fundamentally digitizing everything around us. The fact that I know now what my temperature at my home is on my phone, or whether my garage door is open or not on my phone, is actually examples of digitization that was never present before. That used to be analog in the past. So if everything around us is digitizing and is present in digital form, the question is, what do I need? That's the answer piece. What do I need to leverage that and be successful? And modern data platform comes in. So this is happening regardless whether we do a modern data platform or not, as in digital transformation. That's happening. That everything in the world that we can think of is in digital form. Obviously, pandemic even accelerated it to a great extent. Places where I never imagined that I will do these things from home, signing for a lease from home, signing at for different aspects, all these being done remotely, is fundamentally further accelerating, if you can imagine, digitization. So how do we leverage it? How do we make use of that fact that got recorded in the system somewhere, that digital footprint got created? How do we convert that into data into information into knowledge? That is the question that a modern data platform is answering, and that's the core kind of point that's how that fits in.
Perfect. Thanks, Rajiv. There are some questions. Just want to. So there's a question about from Chidambaram on key metrics business entities should consider to measure outcome for modern data platform. So is the key metrics a driving factor?
Yeah. No, this is awesome. Anything you don't measure, we don't know how well we are progressing. I think it will have to be a session by itself. I'll just leave it at a high level, saying that just like we talked about discoverability, joinability, and governance, can we now put parameters around that and agility as well. So we talked about agility as an outcome. This has 3 tenets of it. That's where all the KPIs you can think of: completeness, quality, responsiveness, performance, scalability. There is a good set of metrics that would measure these aspects. But think on those lines in this limited time. All I'll say is that think on the line that can I measure the fact as to what is my cycle time from a business need changing to business actually receiving it. So cycle time can be measured, cycle time to information and cycle time to action. That cycle time to information is what we are measuring as a key attribute in that case. For discoverability, joinability, and governance, there are similarly metrics which can really provide us this. But the topmost metrics is age-old cycle time to information, but you're measuring for the change, not for the fixed thing, but for things which are changing. How quickly is the system capable of responding to it?
Perfect. Thanks, Rajiv. And then one last question from Rakesh. Any cloud or new age software which can make this MDP transition friction-free?
Yeah. I think we all would love that. But we, I think, all have a career and a job, because I hope still, even with all that there are less way of being able to go one way or the other. I think it's in the methodology, it's in how we approach it. There is work involved, no question about it. Whenever you refactor for something new, when you're going from one way of doing something to new way of doing something, refactoring has to happen. Otherwise, you're just going to put a buggy behind an engine, just like you had a horse before in front. So short answer is there is no silver bullet here. It's about our thought process. Our thought process has to reach there first, saying, am I designing this so that tomorrow when my demand increases and I have just more CPU demand, is my technology stack lined up in a way that I can just supply it more CPU and it'll scale? I don't need to give it a whole new machine with storage and network when it was not needed. That kind of a refactoring and thinking about abstraction, as we talked about, metadata-driven framework, and then let the technology fit into it. There is no one answer. Hence, the best way to look at it is saying that I know the end result. I know what it needs to look like. Now, how does this metadata tool fit into that? How does ETL tool or ELT tool fit into it? That's the way to basically look at it, and find the right rationalized set of technologies.
Perfect. Thanks, Rajiv. I think with this, we are right on time. Thanks for taking time and answering all of this and clarifying and providing a deeper dive thoughts on modern data platform. Thanks for everyone who took time to attend this. Hope you learned something new from the session.